we do. So I'm going to take this very much from the essence of what VM awareness is. It's not going to be super deep. I'm not going to cover every feature. There was a point in time where in 20 minutes I could tell you everything Tintri does, but the product has grown so vast over the last 5 years that I would probably need 5 hours to review every possible combination of features, actions, data services we do. So I'm going to start very much with what I think the essence of VM awareness is. So when you log into any one of our VM store nodes, or you log into our federated management console, Tintri Global Center, what you normally see is a dashboard similar to this, right? We want to greet you with something that you're somewhat familiar with, especially if you're a storage guy, which is, how's my array doing, right? And the reality is, all the stuff you see here is actually a roll-up of all the per VM statistics we have. Remember, we are operating as the VM as the object of management, monitoring, actionability. So this, although it might appear similar to that whole LUN volume view you might be used to, it's actually just a roll-up of all the per VM stats. The interesting thing here is this isn't all flash array we're using, so we no longer show the flash hit ratio. There's no point, it's always 100%. On our hybrids, we did show that. But one of the interesting things we do is in our latency, and I'll go into this a little more when we show the per VM latency, but we have a very cool ability to actually show end-to-end latency within the entire hypervisor stack, right? So we have the ability to know more about latency than just what happens on the array. We can actually see storage network latency, we can see host-based latency, and the two I'm going to talk about when I talk about QoS have been added recently. We call them contention latency and throttle latency. They're latencies that are directly related to QoS that you administrate or apply to a VM. They're very, very critical to the concept of how we do QoS. We think without them, QoS is kind of pointless, right? If you don't know what the effect of setting QoS is, how good is QoS? But this is an interesting thing because when we show it to customers, when they implement this, they often realize the bottleneck was never at storage layer anyway. It was somewhere else. And this is something they can now see basically in one mouse hover action, right?
So, one of the questions I have from Tintri's perspective is it's kind of vVols before vVols, but is it iSCSI? Is it fiber channel? Is it file? What is it?
Yeah, so we wrote a file system, right? That is our intellectual property.
It is a file system storage for virtual machines.
Correct. So when you write a file system, the last thing you want to do is layer another one over it. So layering VMFS on top of our awesome file system wouldn't be the greatest idea. So we purposely, consciously chose file-based protocol. It's the same, and it's interesting is we support SMB for Hyper-V, we support NFS for Rev, OpenStack, VMware, XenServer.
Yeah. So some of the VM specific characteristics that are intrinsic in VMware are there because of plugins and other capabilities. How do you get those sorts of things for the other hypervisors?
For example?
Hyper-V.
So there was a lot of chatter on Twitter a minute ago about APIs. The APIs we actually need are quite basic, right? We need things like, I need to find out what the real name of that object is. I know I know that there's a VM because I see the files, but I need to query the hypervisor manager to find out. I need the ability to add a VM back to inventory. When we do a clone, we don't want to just clone the data blocks. We want to be able to automate adding that VM right back into inventory. So these are actually API things that are pretty common across the hypervisors.
So Justin, maybe Brandon can step in and just talk, because he implemented for Rev, or Mark can step in and just provide a bit more detail.
It's basically just grabbing the inventory, like Justin said. We can tell that there's a VM there, but we're interested in what the user called it rather than just what the file name is.
Right.
For some of the things we do, like the host latency, we do gather statistics from the host side about what latency the VM's experiencing from its side of things. And Hyper-V has that, and
OpenStack's APIs.
OpenStack has that. Most hypervisors have an equivalent API.
So the reality is where I was going with this, is what we need is actually quite basic. After that, after we can see the object, all of our robust data services, that's all Tintri IP. That's all what we built into the file system. And the reality is on this latency graph here, there's only one metric that isn't part of our IP. It's the host-based metric. And as Mark just said, we are able to get that via API via just about any of these hypervisor managers, right? So it sounds like a lot of what we do is so tightly integrated into the API from a hypervisor, and you'd think VMware would be the most robust. But the good news is we were smart enough to not rely so much on it that we couldn't expand and plug in other hypervisors as the market dictated and grew. And we've seen that over time, right? In the last 5 years, we've seen a shift. I wouldn't say a shift away from VMware, but a shift to customers adding a second hypervisor into the mix.
Yeah, and the hard stuff that's required to actually support this is doing very large numbers of virtual machines, doing very large numbers of virtual disks, doing very large numbers of snapshots, and it's not the protocol, right? So nor is it finding what the mapping is from the underlying files to the VMs.
So basically, I just wanted to touch real quickly on the dashboard. Most of our customers don't spend a lot of time here. There is one interesting thing that I think truly is unique, and so we call these two guys the gas gauges. There's a capacity gas gauge and a performance gas gauge. The capacity one is fairly basic. It's what you'd expect every vendor to tell you. What's my free space? What's my use space? What's my snapshot space? How many days till I'm full if I keep up the current pace of if I'm using the storage. We do some neat stuff with snapshotting where we can actually show you hypervisor side snapshots. So if you've got a bunch of rogue hypervisor snapshots out there, we'll detect them and populate the usage in here. But the capacity gas gauge is one that I think is special because I've still, to this day, never seen another product that does this. But what this gas gauge is there to tell you is, empirically, when that node will run out of performance, right? It's never been this easy before. It's been a lot of Excel spreadsheet, back of the napkin math where you're factoring in disk types and disk counts and controller types and speeds and feeds and front end and back end I/O trying to figure out when's my array going to run out of performance. This is pretty much as easy as reading a bar graph, right? So the goal here is that a user can come in and say, I need to add X number more VMs. Do I have capacity? Do I have performance to do that? We want them to be able to make that diagnosis extremely quickly and move on to actually getting the applications provisioned and running, right? So usually customers spend time in the per VM screen, right? So this is really what the essence of VM awareness is. We don't manage runs, volumes, RAID groups, disk types, pools, aggregates. We manage VMs. So normally when you would go deeper into your storage system, you'd see one of those traditional storage constructs. In our world, you're actually seeing the VMs that are running at the hypervisor level, right? It can be a mix, again, of different VMs across different hypervisors. We can support all hypervisor types out of the same array at the same time. You don't need to roll a new one for each different hypervisor you have. And we have a slew of statistics that we can put into our view here, right? So we can do all sorts of things that are performance-based. If I was able to scroll down here, which doesn't look like I can, but we can basically pull up things that are host side, network side. One of the hidden gems in here is something we call I/O realignment. We actually automatically realign misaligned I/O. Used to be a bigger issue than it is now with modern operating systems, but I still have customers who are running really old Linux deployments that can't take an outage to fix the alignment, and they actually just migrate over to Tintri and it fixes themselves. So the point here is there's a ton of statistics that we can show here. We've even set up some default views. So if you said, you know what, I just needed a quick view of my performance stats, we're basically pre-choosing those columns for you and loading them. You can see provision size versus use size. You can see compression and dedupe factors. You can see thick versus thin. One of the nice features that we actually have is the ability to automatically thin in place. So if this was a thick disk, I could come down here and say, you know what, I just want to convert it to thin instantly, right? And it basically just does that in place instead of actually having to do a live migration where you're converting it on the fly. The whole point is no data movement. Do it all in place. What I wanted to do here was show a little bit about what we can do to kind of get some awareness of what the applications and what the VMs are doing from a performance standpoint. So you see here, I just have my VMs sorted by IOP. So I can pretty quickly identify who my high performers are, who my low performers are. I can look at throughput. The one that I like to kind of focus on, obviously, is latency, because to me, that's the true measure of performance for the application, is what is the latency. And for the most part, you see we're healthy. However, I come down here and I do see a VM that's misbehaving, right? This VM has 27 milliseconds of latency. The end users or the app owner are probably already complaining. And as an admin, you're fielding a call going, all I know is people are saying it's slow. Why, right? Without this sort of insight, one, you wouldn't even know which VM to go look at, right? Because you would be seeing some traditional storage construct where you don't see your virtual machines. And two, you wouldn't know what sort of bottleneck you have. In this case, just by hovering over the latency, I already know it's host. Storage network looks healthy. The disk subsystem looks healthy, or flash subsystem rather looks healthy, right? But we're not done here, because you still want to know why. What's happening on my host? Why is the host bottlenecked to 26 milliseconds of latency? The cool part, again, about being VM aware is we can actually go deeper than this. So if I quickly pull up my graph here for this, one of the things that I can do is look at, I can look at that latency over time. And the first question I'm going to ask myself is this just a blip? Is this one of those things where I caught the app at a bad time and it's not really happening? And I realize that this is happening consistently. I go back in time and there's constant host-based latency, right? So one of the things that I can do further to look at this is if I know it's host-based, I'm pretty sure it's going to be either my CPU or memory on the host. That's the bottleneck here. Again, being VM aware, we can go and actually look into that at the host level, and we can see for a given virtual machine, let me pull this into a little more easier to see view here. I'm going to do this so I can scroll down. We look at a couple metrics. We look at CPU ready time, CPU usage, and memory swapping, right? And it's pretty quick to diagnose this guy, because I look at the CPU stats and I go, that's not abnormal. CPU ready time looks good. CPU usage is actually pretty low, but I have these giant spikes of swapping, right? So this is great, because as a storage guy or even as a virtualization guy, I basically did 3 clicks in our UI since I've been talking. I know exactly which VM is having a slowdown. I know that the bottleneck is on the host, and now I know why. It's memory swapping. I can take this information, I can go to an app owner and say, what's the configuration? Do you have enough memory? We can meet with the VM admin and figure out why we have a memory swapping issue. The point is, visibility gets us to the root cause extremely quickly versus either the wheel of blame, where teams are pointing to each other, or 3 days of meetings and running reports across different parts of your infrastructure, still not knowing what's going on.
Is it possible to see all of the VMs that are on that particular host?
Yeah, 100%. So one of the things that we can do is in here I can add the ESX host. So I can add the host, and then what I could do is I could actually filter based on that host, and I could just look at the VMs on that host, right? The goal here wouldn't be to actually fix the issue, especially if it's host side, but it would be to root cause it in a couple clicks, and then take that and say, okay, I now have enough where I can go apply the fix pretty quickly, right? So at that point, I would be able to see, here's the ESX host this is on. I know exactly which host I need to go look at, right? So great point is one more piece of information, and I already know which exact host in my infrastructure I'm going to fix.
And this is management of a single node. We also have a product that manages multiple nodes, Tintri Global Center, and there's a lot of filtering you can do, right? You can do the host, you can also do wildcards. At scale, you really need to be able to filter down to a smaller number of VMs.
Yes.
One of the other nice things that we do here with very quick and easy visibility and troubleshooting is sometimes we like to just go back to those node level VM store array level graphs and look at I/O or throughput in totality. And we can see sometimes that there are spikes. So here's an example of a point in time where I/O went up. And as an admin, we might want to know why. What happened in this period of time where I/O went up, right? Normally that's a question that often goes unanswered. It's very hard to answer, especially if it's something that happened historically, right? 30 days ago. You just don't have the ability to roll back your environment to figure that out. With us, we literally can click at any point in time in any of these graphs and we will tell you exactly which VM, as well as the top 10 VMs that were contributing at that time. So again, the answer to one of these performance spikes, it could be I/O, it could be throughput, it could be latency. On a hybrid, it could be a flash miss. We want to know which VM had the flash miss. It's no longer a guessing game. It's one click, right? So this is great because this alone, I've seen real world scenarios where customers have discovered systems that are doing things that they thought they disabled, scheduled tasks, backup jobs that they thought were not happening anymore. They let it, they move them over. A week later, they look at these patterns. They see something happening at 2 in the morning. Go, that looks weird. Click on it. They pinpoint the VM, and they're able to troubleshoot inside that VM and figure out what's going on. The last thing I wanted to show you was around quality of service, right? So we actually have here a system running both VMware and Hyper-V. So this happens to be one of our Hyper-V VMs. I'm going to do something real quick here while I pull up 2 graphs. I want to do a graph over graph. And I want to look at, well, let me pull this up real quick. I want to look at both latency and I/O at the same time. There we go. So this VM, again, Hyper-V VM, it's running a fairly big load. Let me see if we can see. It's doing about 16,000 IOPS right now. We have the ability to quickly look at its QoS settings. So I have my default QoS view up here. I can see that I've guaranteed the VM so far 2,000 IOPS, but I haven't set a max. So QoS is very easy to set. It can be done automatically with either PowerShell or PowerShell Toolkit or a REST-based API, or through any of our UI with just the ability to set QoS, right? So I can come in here and say I want to configure QoS. So right now, the max is unbounded. I'm just guaranteeing this VM, basically 2,000 IOPS. I'm saying if there's ever contention, I want to make sure you have 2,000 IOPS regardless. But it could be a scenario where I know this VM goes berserk from time to time and I actually don't need it to be unbounded. I want to limit it. So in this case, what I'm going to do is I'm going to set the QoS setting to maybe half of what it's doing now. So instead of its normal 16,000 IOPS, I'm just going to give it 7,000. Now, this might sound like a good idea when we talk it over with our app owner and say, yeah, we want to limit this. But if we set this and we had no visibility and no reporting on it, we wouldn't know if that setting actually was good or bad for the application. And this is what we think is the fatal flaw of many of the other QoS implementations out there. Well, A, they're not at the VM level. They're low volume based. So you're applying QoS to dozens of VMs. The second one is there's zero visibility, and if that setting you just set is healthy for the VM. What you'll notice is immediately as I set that, and if you notice at the very end, the I/O goes right down to that max, right? This isn't something that needs not even a warm up, a spin down, a cool down time. It's immediate. And what you also notice is that latency has been injected into the VM. So right before that, what we were doing was a total latency of 0.6 milliseconds, right? Now what we're doing is about 3.4, 2.9 of which is what we call throttle latency. This is artificial latency that's been injected because we're forcefully maxing that VM, right? So this is the part where we think is critical. We think QoS without this visibility of either throttle or the purple latency, which is called contention latency, is basically useless, right? The only way you know that you would have a problem is waiting for the phone to ring and have somebody complain. We felt that this level of visibility was paramount to any sort of successful QoS implementation.
Can you do that on groups of VMs at a time instead of just an individual VM?
So there's a couple ways to do this. There's something we have called service groups, which is a logical grouping of VMs. I'm not sure if we can actually select multiple groups and apply it that way, just right-click and select with the UI. I think what we would do is put them into a service group and apply QoS policy to that service group, right? So if you wanted your SharePoint environment to have a guaranteed minimum, you could put them all in there, right?
Do anything predictive over historical time to give you we're seeing it could be set here and.
Yeah, so here's Gabe, here's the way I look at this. With great power comes great responsibility. We have fully automated QoS. We've had it in since day one. That works and is recommended 99% of the time. We don't recommend that customers go and manually or administratively apply QoS manually. It's really for the use cases where you know you need to guarantee an application a minimum level, or you wish to cap a VM. So it's typically a small percentage of the environment that these things even come up. And often what we do is we tell somebody to, here, I'll drag this back up so you guys in the meantime can see what happens when I drag it back up. We would literally tell somebody, hey, go look at the 7-day or the 30-day view and find that high water mark. And if you wanted to adjust it, you can do so that way. So there's nothing predictive, but we don't recommend, just because the feature's there, to go apply it to hundreds of VMs en masse. The reason we actually included the visibility is because we thought customers were going to do that, and without them knowing what the effect of setting QoS was, they could have turned a perfectly healthy half a millisecond latency environment into a 30 millisecond latency environment by artificially injecting contention and throttle latency into their world. The last thing I want to leave you with is basically just our list of data services, right? So again, any VM, doesn't matter the hypervisor, we can right click and perform actions, right? So we have protection. This is a combination of setting a snapshot on a replication policy. This works regardless of hypervisor. The beauty is actually in what you don't see, which is you don't see a difference between these things in their hypervisor. You set up your policy, you click one box to set up replication. So literally, I just set up replication by clicking that box. I choose a destination. I can choose my retention period. So if I wanted a week locally and 2 weeks remotely, I could do that. And I literally hit protect. That replication setting is now set up. We also have introduced recently 1-minute replication, right? With even more efficient things to follow and coming soon. But of course, like any storage subsystem you would expect, snapshotting, replicating, cloning, it's all in there, it's all per VM, it's all space efficient. The good news is even our cloning allows us to do things to add back to inventory, right? So I can basically choose the point I want to clone from, whether that's a previous snapshot or the current state. I can choose a new name. I can choose a path. You notice this is a Hyper-V share. It detected automatically which type of hypervisor was on. It's not showing me names of VMware data stores. It's showing me my Hyper-V shares. And I can even choose which host to put it on, if there were multiple in there, and then I get a clone count. So basically cloning this will not only create the new VMs, it'll add it right back into inventory for you. Right? The only thing we stop short of is powering it on, because we assume you may or may not want it powered on. We don't want to take that step for you. But that, however, could be part of the PowerShell automation if you wanted to do any of this through PowerShell. And that's kind of the last thing. If we have time, Christopher's going to kind of go deep into Sync VM, which is an extremely powerful sort of data manipulation, time travel, if you will, for your data feature. But he's the expert on that. I'm going to let him do that. So that's kind of what I had. Keep the questions coming on Twitter. I'll try to answer them.
So there's no synchronous replication. It's just async?
So
Yeah, we will have synchronous replication later this year.
now that Kieran said it, I can say it.
Yeah.
Sync rep is on the roadmap, right? So we're down to 1 minute now. Full sync is coming. It'll be, again, configurable per VM. So what we've often discovered is it's a portion of customers' environments that actually require sync rep. It's not 2,000 VMs, it's 12. And so that's kind of the nice ability to say, I actually want different replication policies per VM or per service groupings of VMs.
And then, like, you have an SRM or SRA solution to work with VMware?
We have we've had an SRA for a while, so fully compatible with SRM. Yes.
Cool.
Any other questions?
Is it still a Flash interface or is it HTML5?
Great question. So I don't know how Kieran wants me to answer that one. The current one is, let's just say the current one is Flex based. We said, hey, VMware is doing all this stuff in Flex. We're gonna mirror them. There's a direction to make things nicer, more seamless, pretty, and more universal across TGC and VMstore UI.
Okay.
So you can expect modernization over time. So,
Okay.
Yeah.